Thank you, gentlemen. You all actually gave an interesting challenges. And so we have the old guys with a lot of experience, and we have here the young contenders. Yeah. So it's interesting to see if they can learn something from another. And if I just look at this setup, this is already a perfect setup for a first question. Is he something like your 40-year-old kid or 24-year-old kid, which you can learn from?
Now that gets insulting.
No, I meant seriously, because as you can see, he approaches from a different angle, from the platform angle. Is this the kind, actually, of a platform you're looking for? Or would you say, well, guy, you haven't missed, you didn't understand my full structure. So what can we learn there?
That's a good question. I think in general, less about you particularly, but I think in general, we do seem to see, as some of us have pointed out here on stage, there's a repeat of things happening it seems like every 10, 15 years, right? Where we start with a file system, and we always come back to a file system. And for some reason, we think this time around, the file system is the real solution to it, right? So I do believe that there's something to be said about learnings over the last, actually several decades, way before my time, actually. Having said that, there's also something to be learned, and we didn't get a lot to talk about cloud and DevOps and agility on how to, containerize platforms, because where the world is going with Docker and with microservices and whatnot, there's a lot of opportunity there, I think, to do things differently. There's also a lot of chance to screw things up yet again, because, as we know, you can overdo microservices just as well and lose governance on top of that, and then you're in just as big of a mess, right? So I think it's about a balance where new and old always need to, it's the pendulum, right, that keeps going from the left to the right. Somewhere in the middle is probably the sweet spot where we need to end up.
You would agree? Good, thank you. So he already learned his lessons. That's great. So,
I would like to add to what Oliver said. Yes, things can be can go wrong again, but I'm optimistic, and I think the wind is very strong, and I think the wind of change, of course. And what happened with Amazon EC2? This company that delivers a service and APIs and changes completely the IT landscape, and no one can do things today as if EC2 doesn't exist, right? So I think now there's some form of we are going to the right directions, and there's no way back, I think.
Yeah.
Okay. If there's anybody here who would like to challenge the beers, don't hesitate to stand up and challenge them. Otherwise, I will just continue. There. Can we have a mic there? So we got now into the snowy world.
Yeah, Martin Henschel from Snowflake Computing. I'm interested in integrating R and Python into SQL. Is that a fundamental shortage of SQL as a programming language? Because we've heard that schema is very important, and it is, and SQL is a great tool to analyze data and importantly relational data that has a schema. But now we see that we also need R, maybe Python, to analyze the data, and integrating it into SQL. There's a little bit of a language gap in that, and my question is, is there something fundamentally missing from SQL? Is SQL not enough, or is it just a hacky way of integrating statistical analysis into the SQL language?
Okay, so we have a few system builders. Well, first, Paul, you already had your chance on the R integration. So, Paul, educate.
So, for my first introduction to sort of SYN and decrepitude was working on a system called Postgres in 1990 through 1994. All of the syntax that you've seen in the slides above, the ability to integrate Python functions, the ability to integrate eventually even R table functions into a database platform was essentially, that was what Postgres did. And most recently, the guy called Mike Stonebreaker, who was the Postgres lead, he won the Turing Award in part for that kind of work. So the ability to introduce imperative language calls as functions, as aggregates, as user-defined types and functions as the domain syntax and so forth, that's been part of SQL since practically forever. And people use it. If you use Postgres PostGIS, it's essentially the embedding of a collection of quite sophisticated geospatial routines into a Postgres engine. Postgres users writing SQL can reason about the data that they have in their engine, the user-defined, the latitude, longitude, the timestamps, and so forth, simply using SQL as a framework language. That's typically, at this stage of the game, almost a solved problem. We know how to parallelize these functions. We know how to make them work. All SQL engines currently support this kind of functionality to a greater or lesser extent. But here's the fundamental question I think you're really asking. If I'm taking a language like Python, I don't want to write necessarily routines in Python code and just drop them into SQL. Rather, I want my SQL database engine to look like a NumPy interface or a SciPy interface. I want objects in that database engine to be indistinguishable from objects that are just present in my localized namespace. That's a fundamentally harder problem. It's actually, and there are some people doing some good work with this. If you go to the CRAN postings or the CRAN site where a lot of the R extenders live, you'll find there are people who are doing things like taking an R data frame and hooking it up to an MPI backend. So you've got a bunch of data that looks like an R data frame object, but then when you do an operation like a multiply or transpose or some sort of transformation, that's intercepted in the R interpreter, handed back to the big N server, and the big N server is where all that happens at very, very large scale. So there are two questions when it comes to integrating languages and databases. One has effectively been solved since the early 90s, user-defined types, functions, routines, and so forth. But the really interesting work today is being done on the client side. How do I essentially make SQL-like objects invisible to the client user? How can I make our users just look like they've got a massively scalable back end?
Before your answer, first go the other side, because you were also mentioning it, some of the limitations of R in your world.
So what do you want to know?
Well, how can they help you?
First of all,
Tools, it's always the same. Yeah? You have to find the right knob.
I think with R, Mathematica, MATLAB, and LabVIEW, and all this, for us it is obvious. We are not going to reinvent the wheel if the wheel has already been invented. It takes some time, to move from, day 1 to day 2, because these tools are evolving. What I see in general, the data analysis in my mind is like a tree. So you can have things that are trivial. You click on a mouse and you have some menus. You have a nice graphical user interface, and you click and you see these things. Then you have other things you can do with scripting language. We have seen Perl, we have seen fights between the Ruby people, the Python people, and so on. And I'm sure this will evolve in time. So I think if you can do things with scripting language, fine. Okay? I don't care at all about the complexity of these things. Now, personally, I've seen people have no difficulty in general to go to crazy language like C++, like we had in the old past in Fortran. Because if they can express themselves, if I know the kind of things they do, they have to write maybe a bit more complex piece of code than just what you can do with just pure R or a command line. So I don't think this is a problem in a long time. The problem is that you want to use all these tools, so you want to use a GUI where the GUI makes sense, and you are going to use the programming language where the programming makes sense, because you need to be fast, you need to be 100 times faster than what you can do with Python or with IPython and company.
Okay, so but the question was, what is the fundamental problem if you take a language like R into a database community? Paul answered, at the syntax level, there is no issue at all. It's all done. It's all schoolbook. You have a different opinion on that?
Actually, I mean, I agree that doing on-demand UDFs is something that is a very old concept. There's several points to it. One is, of course, speed. You know, the translation between the two worlds needs to be efficient, and that's something that we found with the experiments. For example, with Postgres, if you go with PLR, which is the embedded R for Postgres, for example, if you go between these two worlds, it's insanely expensive because you need to go from a row major format to a column major format, and that's something that you have to work with there. The other thing that makes this a bit more complicated than, you know, simply dropping functions there is that in SQL you have constraints regarding the cardinalities that your user-defined functions have. For example, if you are a filter function, then you're expected to return exactly as many rows as your input rows, Boolean values as your input rows, and that's something that, you know, enforcing this in a language is not so simple. The question why you would want to do this and why you would not just use plain SQL is twofold. I mean, we have an astronomer in our group who is extremely good in expressing complex algorithms in SQL, and every time I'm amazed what he can do. I don't think there's many people like him. And I think we cannot ignore the vast body of knowledge, thousands of packages of statistical analyses that people have implemented, that we simply cannot say, all right, we just, you know, you write a SQL function that does it. And depending on what your SQL interpreter can do, things like iterative processes is also very difficult to implement, and especially for learning processes where you iterate to a fixed point, I think doing that in SQL is simply was not considered. So you probably want some imperative things in there to get this sort of thing working.
Okay, so harvesting all the knowledge itself. You want to add something to that? You're also the R expert.
Yeah, actually, we touched upon a point which is extremely crucial. You mentioned a data frame that actually would, on the background, will manipulate a table in a database. And actually, we are touching here upon something which is very important. It's the design and the interaction design that would allow and empower the users by making them basically manipulate complex things in a very effective and transparent and seamless way. The challenge of making things go fast is huge, but the challenge of making things simple is at least as big. And we need to think of both. I fully agree also with René on the multi-layered approach. So basically, as it comes to data analysis, basically there is a layer where we will have always the dirty stuff. You know, but we need to put on top of that layer other layers that would expose things differently. So there is a metaphor of perspectives. You know, we need to imagine the different perspectives that would make things look differently according to the problem domain that we are tackling and to the type of users and stakeholders that are involved.
Okay, you want to add?
Can I add something to that? I think what we are seeing here is that maybe 20 years ago, we tried to build one system that could do it all, right? And we would try to cram more and more into a particular system to make it do all these different things. I think what we are realizing, at least from our point of view, is we're starting realizing it's an ecosystem that needs to come together, right? And that ecosystem nowadays, I mean, technology has evolved to a point where the fabric that connects compute nodes, for example, together has become so powerful that it's no longer in the way of talking data to each other, right? Nowadays, we're talking InfiniBand. We're on the verge of getting to 100 gigabit interconnects. Intel is putting interconnects onto the CPUs for the very same reason, so that we can talk to remote nodes as fast or faster as we have been used to talk to local storage. And if you take that for a second here and think about what we need to do, it's almost, you have best-in-class functions that need to pipeline data through each other, right? There's a reason why we do SQL, because if we do 1 trillion records joined with 100 billion other records, you want an optimizer to find the smartest and cheapest way, and not a human being that by making a mistake picks the wrong plan, right? Having said that, you then need to pipeline the result set of that through algorithms. They might sit on a very different CPU and a very different memory structure, and you need to be able to live in an ecosystem, right? That does that data, because you can't create all functions locally in a single system, or you end up with a 100 million lines of code kind of monster that is simply unmanageable. That's where simplicity goes out the window.
Okay, thank you. Thank you very much for pointing out actually an ecosystem. We have to go to an ecosystem of the components fitting together. And we are here in an ecosystem of people and brains. So I'm looking for another question to the panelists. There's the mic. So if you just run. Good exercise here.
Hi, I'm Dave Cuthbert from Amazon Web Services. And actually, to follow on to your point, question, or actually what I have is more of a challenge I'd like to kind of issue to you. So something magical happened in the 90s where I could suddenly, on this clunky old desktop computer, take the spreadsheet I was working on, create a graph, and then dump it into a document that I was working on. Olay back in those days, COM, et cetera. And back then, this was sufficient because everything I was doing was on one box. Now we've gone to different services, different platforms, et cetera. Now, 90% of the people in this room wouldn't have any problem with that. We're all because we understand what are the boundaries of the platforms. But now, how do our users, who aren't so savvy about this, how do they take something that a person over here has developed in Elasticard, put it into a Teradata system over here, and then where can we come up with some commonality here or some kind of transfer language here that makes it independent, or makes it transparent to these less savvy users?
So this is actually a call for a sales pitch. 1 minute. Why Teradata is a new platform where actually an average user can throw in their stuff and get some information out for their business. 1 minute.
I actually tried to stay from a sales pitch here, but if you force me to. No, I think you're onto something here, right? I don't think that anybody in the industry has the end-all solution for that, right? I think we are making steps towards that, right? If you look at how we at Teradata look at it, we call it query grid. We talk about how do we connect different platforms through adapters to each other, use a fabric in between to make these different platforms stream with each other. The problem is the language, right? The problem is what's the construct that we put in front of the users. And what we are seeing right now is that the vast majority of users that talk to our systems are still coming through SQL, right? And it's the tableaus and it's the vast majority of tools. And yes, then there's data scientists and then there's statisticians that have a very different set of tools and a very different set of requirements, right? And Nahum can talk a lot about that coming from his point. And I don't think we as an industry have a solution for that, quite honestly, right? I think we're making steps towards it, right? We're trying to do it in simple steps and not boil the ocean. But there's no one language that I see right now that solves it all.
Good.
Can I?
Relational algebra. Can't everyone just speak relational algebra? We use that as a backbone behind all these technologies.
So this, of course, is the brave man. Please stand up and read the question with a mic, because you're actually here in the lion's pit. And so, your name, your statement.
My name is Julian Hyde. So, yeah, it seems like SQL is being used as like the straw man here. I don't like SQL, therefore I'm not going to use a database, and I'm not going to do things in a database-like way. And, the kind of takeaway from databases is declarative is good, optimization is good. SQL is not a necessary part of a database. There's lots of databases that don't use SQL. The kind of underlying framework is basically relational algebra, something like relational algebra, the idea of processing queries using data flow.
Okay,
and so why can't all of these machine learning tools speak something like that so they can interoperate with each other?
Great challenge. Just great challenge. Also knowing that, of course, he's going to give a talk this afternoon on where he actually will explain that the components Hannes was talking to, an independent optimizer is the way to go. But we will hear the beers. So the beers, of course, will answer you. So who will take the lead?
Let me give you some perspective. Those of you with notice I didn't comment much because unlike these distinguished people, I'm not coming from database. I'm using database as a tool, mostly as a part in my presentation. I'm using the tool in order to do basically the data manipulation and some data managing, etc. But data science, the one that I didn't talk about, has a lot of very sophisticated algorithms. For example, there is a lot of progress being made in the last 10 or so years, 8 years, in deep learning. Do you want to take deep neural network and implement them in SQL? I mean, cool. Go for it, man. If you can, that's fine. By the time you are done, there will be another way to do that. And if in the SQL you use it in the CPU, they will come up with much faster through GPU. I mean, there are all kinds of things. People are moving very fast with a solution. They want to some problems. And if someone stands in the back and say, I want to adopt them to my own language, by the time you're done, you may be too late. And so my point is, and I agree with Oliver, that you need an ecosystem when you can use your own tools, the tools that you want to do, and the crux of the matter, in my opinion, again, my opinion as data scientist, is the crux of the matter is fast movement of data from one platform to another on a temporary basis. If I did some manipulation on the data in Teradata or in Hadoop and in others, and I want to move them into in-memory cluster, can I move them very fast, interactively almost, hundreds of terabytes, run my algorithm there, create the results, and then drop the data and no harm done. If this can be done, a lot of that stuff, in my opinion, can be solved.
Okay, thank you. That's far away from the relational algebra, but of course, Paul, of course, has always the right answer.
I always have an answer. So I'm just going to sort of pick up the idea of the relational idea, and I want to just, as a bit of background, I was sort of one of the object relational crew from about 95 through about 2000, which essentially said that you pick up the relational algebra, you make domains work properly, and so on and so forth, and magically a lot of things fall out of that, and indeed it was a good and it was true. But I'll just lean back a little bit on one point, which is that relational algebra, set theoretic, first-order predicate calculus, all that sort of good stuff, it isn't the only algebra out there. There are other algebras. I'm with SciDB. I'm here to help you. We're building an engine that builds itself on an array algebra. So it's the same idea. It's data flow. It's building blocks. But the result is the semantics of what we can do for certain problems is much more natural for folk who are familiar with data science. Simple example. If you try to use a statistical technique, like what's called principal components analysis, you're trying to figure out which of the components of a model are the most significant, and that involves an underlying operation, a linear algebra operation called singular value decomposition. That's a bear to implement in SQL. Further, if you're using that technique in some other system that's an iterative model that sort of, as was pointed out, that iterates to convergence, it becomes awfully hard to do in just set theoretical operations. But if you've got an algebra that looks a bit like APL, which was a very old programming language from the late 60s, early 70s, that we understand how to optimize this stuff, how to reorder operations, we understand how to do iteration to conversion. I'm not saying it's better, I'm not saying it's worse, just saying it's different and possibly equivalent.
Thank you. So there is much more than that. For relational algebra, let's get the fixed point operator, and we're halfway. And then, of course, we even touched actually the other line is that life should all be around Haskell, because that's also a good way to play the game.